QSO Today, episode 229, Keith Baker, KB1SF. This episode of QSO Today is sponsored by ICOM America, makers of the finest HF, VHF, and UHF transceivers for every level of the amateur radio operator. Visit ICOM at www.icomamerica.com/amateur and update your holiday wish list. And by QRP Labs, makers of the QCX single-band transceiver kit and a host of other QRP kits and parts for the ham radio builder. Click on the link to QRP Labs in this week's show notes page. Please support the QSO Today podcast by supporting these fine sponsors. Welcome to the QSO Today podcast. I'm Eric Guth Z1UG, your host. Did you know that amateur radio operators through AMSAT, the Amateur Radio Satellite Corporation, have launched over 95 satellites into space since 1961? I didn't know this until I spoke with my guest today, Keith Baker, KB1SF, former president and now treasurer of AMSAT. If you have an interest in amateur radio satellites, what is happening on the front, and how to get involved, Keith shares his wealth of satellite knowledge in this episode of QSO Today. KB1SF, this is Eric, 4Z1UG. Are you there, Keith?
I am. Very good afternoon, good evening.
Whatever it is.
Whatever it is.
Keith, thanks for joining me on the QSO Today podcast. Can we start at the beginning of your ham radio story? When and how did it start for you?
Well, actually, Eric, it started out for me in broadcasting. I was always enthralled with the fact of listening to the local radio stations and also listening to AMDX, listening late at night on a original 6-transistor radio way back in the 60s, and I eventually got into broadcasting with my local radio station when I was in high school. And it helped because one of our neighbors owned the station, and I went up to her and said, "Hey, can I be on the radio?" And she said, "Well, go on up and talk to so and so at the station." And literally sat down inside one of the recording studios and taught myself how to be a DJ. So from there, I went to the University of New Hampshire and worked in broadcasting there, and then also worked commercially on the weekends throughout New England. And at that point, went into the U.S. Air Force and was off doing some other things and getting myself settled, getting the family settled. One of my coworkers at Wright-Patterson Air Force Base, where I was stationed, we got talking about Citizens Band, and he said, "Well, why don't you get your ham license?" And I said, that's one of the things that I always have wanted to do, but never really had anybody take me under their wing and give me an idea of what has to happen. And of course, at that point, the U.S. still had what was called a novice license, which was available by mail, and the testing was done by a fellow ham. And so he gave me my test, and this gentleman's name, by the way, is Jack Mitchell. Now his call sign is AA8Q. And being in Dayton, Ohio, which of course is the home of the big hamvention, he was very active with the Dayton Amateur Radio Association. And at that point, I got my novice license and got on the air, and I was living in base housing at the time, so I had to join MARS, which was the military affiliate radio system, in order to put up an antenna. And another gentleman who was also in the same complex and also worked in the same office that I worked in was another ham. His name was Carl Thurber, W8FX. And Carl took me under his wing as well. So I sort of had two Elmers back in the mid-'70s when I first became licensed as a ham radio operator.
And what was your first call sign?
My first call sign was WD8CMU. Which was a novice call at the time, and they had dropped the individual identifiers for novices just about the same time. And they also had changed the licensing so that you didn't have to upgrade right away. You could basically become a novice and stay a novice for the rest of your career as a ham, but I didn't want to do that, and soon went up through the ladders to general and then to advanced. And so from that point, I was really interested in DX, and that's, as we were talking earlier, I said that was my first love, was working the DX to see how far away my signal could be heard, not necessarily to count countries or that sort of thing, but just to know that something that I was doing either with my voice or at that time with Morse code, and I still am a very avid Morse code operator, was being heard on the other side of the planet. That was just a thrill and has always been a thrill for me and will remain that way probably until I die as a ham.
I wanted to back up just for a second. You said that because you lived at Wright-Patterson Air Force Base and you're a ham on the base, that you had to join Mars, and did you have to operate Mars, or was that just a condition of being on the base?
Yes, and if you wanted to erect an antenna and operate from the Air Force base housing, you had to be a member of the Air Force, or it would be the Air Force Mars program. And of course, that's a whole, we could spend hours talking about Mars as well. But yeah, that was basically a requirement.
This was during the 70s, and this was before we exited the Vietnam War?
Oh, yeah. Yeah, we were still at that point, and they were still doing phone patches from folks in Vietnam back to the U.S. So, yeah, it was still very much a morale and welfare operation, as well as providing emergency backup communications for the military in times of emergency.
I don't think there's a better place, frankly, in the country but Dayton, Ohio, to get your first license and then have the hamvention, right?
And what was interesting, Eric, is that I had been there for about 3 years and was totally oblivious that the hamvention was even going on. So
it seems to be one of the most important events of the area now, and maybe that wasn't true then, but I think it is true now.
Very much so. It still was. Oh, it was very much. And it wasn't until I got my license, and of course Jack Mitchell, my Elmer, was very much wrapped up in the Dayton Amateur Radio Association, who are the sponsors of the hamvention. And of course, as soon as I had an opportunity after I was licensed, there I was at the front door, going, "Wow, this is great. It's it's right next door."
Yeah, it's pretty amazing. I've been myself one time, and I hope to go again at some point. Let me ask you. Okay, so you're in base housing. What was your first rig there? How did they set you up?
It was an HW101, built from a kit, Heath kit. It was a transceiver, and we had an opportunity to build it. In fact, Jack helped me do some of the troubleshooting on it. So I had my Elmer right close by, and he helped me get it up on the air. And yeah, away we went. 100 watts and a vertical antenna stuck in the middle of the wife's garden, which we think helped make the flowers grow.
Oh, absolutely. What else could there be? and that was a great rig in those days. And so so you say, did you start working DX as a novice with the HW101?
Yep, you bet. And it was of course it was CW at that time, and we were kind of, as I remember, at the bottom of a sunspot cycle back in '76. And so most, the first, as they say in ham radio, DX is anything that you haven't worked yet. And, you start, your horizon starts as you're working all states, and then you're working all continents. And I still remember to this day, the first time, I think my first real DX contact was a gentleman in Finland on the novice bands, of 100 watts CW to a 18 AVT high gain vertical in the middle of the garden. That was, that's like your first contact. And, it was, it was amazing. It's still a thrill to me. Even now with, I don't know, the last I checked on Logbook of the World, I think I put all of my logs from all the way back to the beginning are up on Logbook of the World right now. And I think I'm up to about 28 or 29,000 QSOs. And I still get a kick out of hearing my call sign come back from the other side of the planet. It's just, it's very, very, and of course nowadays with cell phones and all the rest of that, it's not a big deal for some of the younger set, but boy, for for a person that was raised in the world of radio, that's still a thrill.
Were you career military?
Yes. Yeah, I retired. I did 20 years in the U.S. Air Force, retired as a major. Everybody said, "What did you fly?" And I said, "I flew a desk." I was a financial guy, and retired. Actually went I was stationed at Wright-Patterson for my first tour, and then went from there down to Texas. Taught our schoolhouse for the financial side of things that I was involved with. Went up to SAC headquarters, lived and worked within 25 feet of the red phone, Dr. Strangelove and all of that.
That's Colorado Springs?
Nope, Omaha, Nebraska.
Oh, okay. SAC is what, Strategic Air Command?
Yep, it was SAC. I was in the headquarters, and then from there I went over to be the controller of Aviano Air Base in Italy, which is not too far from where you are, and then came back to Wright-Patterson and retired. So I started out at Wright-Patterson and then went back to Wright-Patterson at the end of my tour in Dayton. So of my 20 years, I spent 10 years in Dayton. So had a real good dose of hamvention during that period of time.
And how much time did you live in Italy?
I was there for 3 years, normal 3-year tour. Lived just north. Aviano is just northeast of Venice, if you're familiar with that part of the world. And we were just at the end of the Cold War was winding down at that point, and there was still a lot of activity going on, but it was doing well.
How did you find operating in Italy? Were you involved with the hams in Italy?
Oh yes. In fact, I remember I went to a ham club meeting, and they were arguing about someone's repeater up on one of the big mountains was being interfered with by another repeater from somewhere else. And I turned to my friend who was sitting next to me, and I said, "Well, that just tells you that amateur radio is a universal hobby because we argue about the same things throughout the world."
Yeah, that's pretty amazing. Did you ever get back into broadcasting?
No, I haven't. I had thought about it, and one of the other things that I'm doing lately is I've struck up a friendship with Ted Randall, who is running a shortwave station here in Tennessee. And he is a ham, and he does basically the same sort of thing that you're doing, Eric. He has guests on he has a program called QSO Radio Show, and it's broadcast on shortwave. And also he does, it does a podcast type thing. He has a server and so forth. But that's as close as I've gotten back into broadcasting since I retired and have done ham radio work. But I still kind of dabble in that, in the sense that Ted and I kind of kick ideas around, and some of the stuff that he's trying to do. Basically, what he's doing is he's acquired the services of some of the old radio DJs from some of the big rock and roll stations here in the States, and he's got them volunteering to do various lengths of time playing the 60s and 70s, the 60s predominantly, on a program in the evenings, which is broadcast worldwide. So,
wow. I could listen to Robert W. Morgan, 93 KHJ, or something like that.
You could. Well, most of these guys were from CKLW here in Detroit, just south of where I am. But, you give a listen, 5085 in the evenings, and it's WTWW. We transmit worldwide .us, and you can listen live at any time. He's got a live stream going.
When people say that they're retired career military, that means that they could have retired in their mid-40s.
Yes, that's right.
So what does a guy like you do as a retired person in his mid-40s?
Well, what I ended up doing originally was because my wife and I had waited for roughly 20 years to have our first child, I became the dad while she finished up some of the work that she did. But I also had my own consulting business doing financial consulting and project management consulting with a partner in the Dayton area for many years. So, I started out branched out on my own to have essentially a second career which now I'm retired and just relaxing and having a good time with life.
Now, I was looking on your website, and your website shows that you have 2 QTHs, and you just said to me that you're in Tennessee right now, or that you live in Tennessee, but you also are living in Canada. How does that work?
Well, actually, I'm not living in Tennessee. I'm living in Canada. I married a Canadian lady. My first wife passed away. So the daughter and I emigrated to Canada, and I met my lady who's here. She's an amateur radio operator as well. But I'm living just across the U.S.-Canadian border from the United States in a little town called Corunna, which is right at the southern end of the big Lake Huron, one of our big Great Lakes over here. So I go back and forth to the U.S. In fact, my U.S. cell phone works while I'm sitting in my living room in Canada. And we go back and forth across the bridge. There's a river that runs between Lake Huron down alongside of the city of Detroit into one of the other big lakes, Great Lakes, which is Lake Erie. But that forms the border. Those lakes form the border between the U.S. and Canada in these parts. So as I said, because I'm still retired military and I have a lot of connections with the U.S., we go back and forth across the U.S. border, probably once a week. And I have to be careful because I still have my U.S. Call sign. And, of course, I have a Canadian call sign, and we can also have more than one call sign over here. So I essentially have 3 call signs at the moment, 1 in the U.S. and 2 in Canada. But anyway, I have to remember where I am because sometimes I'll start a conversation on, let's say, on a 2-meter repeater in the U.S., and I'll finish the conversation. I'll start with my U.S. call sign, and I have to finish it with my Canadian call sign because I've gone across the bridge into Canada.
Well, so anybody out there, any app developers out there, could make you an app, right? That tells you where, what call sign to you as you're driving across. Maybe it flashes up on Waze.
Well, something. And more than once I've made the mistake, even on HF sometimes, because if I come back from and I frequently we travel back and forth and spend time in South Carolina too. We have particularly the Canadians like to get out of the snow and the cold, so they call us snowbirds. And so we'll end up going down for a week or so into South Carolina during the wintertime. And I'll, of course, be using my U.S. call sign down there. Well, sometimes when I come back and get on the air over on the Canadian side, I'll end up giving my U.S. call out during a contact. And so I have to catch myself sometimes, and vice versa. Sometimes when I'm down in the States, I'll immediately pop my Canadian call sign instead of the correct one. But, the way I look at it, they're all legal call signs, and it's just a matter of making sure everybody knows where you are.
Okay, so do you maintain a house in the United States as well?
No.
Oh, okay.
I just have a mailing address, which is what you have to have for your U.S. license. As long as you have a postal address, and it can be borrowed. It doesn't have to be a permanent house of any kind.
Right, I do the same thing. What's the current rig?
I've got several. At the moment, I'm using, in my main shack, I'm running an FT2000 Yaesu and an AL82 Ameritron amplifier. I still don't have a big beam antenna up. I'm still running basically a G5RV dipole, which seems to work just fine. And I can go between. I have switching between. I also have a shack, which I use predominantly for satellite work.
And it looks like a shack from what I see, right, in the pictures.
It is literally a shack. It is a ham shack. It's a shed. Canadians love to have backyard sheds. So this is a backyard shed where we store lawnmowers and that sort of thing. It's unheated, so I can't really be out there in the middle of the winter. But during the spring and summer, when a cool day, I'll be out there with a radio, and that's predominantly where I do a lot of my satellite communications.
Oh, so that sounds really cool.
Oh, it's a lot of fun.
And now this message from ICOM America. As we get past the contest season and into the holidays, it's now time to put an ICOM radio on your holiday wish list. Normally, when we speak of ICOM and its line of ham radio products, we normally speak about ham radio transceivers. However, did you know that ICOM America has a full line of radio equipment for aviation, land mobile, marine, and general coverage receivers for listening? So this week I want to talk about the ICOM ICR30 dual band and reel recording receiver. This is a holiday gift for anyone who is interested in listening to radio signals between DC and blue light. All kidding aside, this ICOM ICR30 covers from 100 kHz to 3.3 GHz. You can easily listen to your favorite 80-meter nighttime net while at the same time listening to your local police, fire, and rescue channels. This is a scanner on steroids that allows you to listen to analog single sideband, AM, FM, CW, and wideband FM. The ICR30 also decodes P25, NXDN, and D-Star. In addition, you can monitor your local repeaters using CTCSS and DTCSS. Users of the ICR30 can monitor HF and UHF signals simultaneously and can scan for other channels on the B channel side while receiving the main signal on the A channel band. Using the dual watch mode, this portable receiver can individually record the audio of the two bands received onto a micro SD card in WAV format. A built-in GPS receiver displays your current location and can be used to locate stations within 100 miles providing that you program the station's position in advance. Connect your wireless headset with Bluetooth. And finally, there's both Android and iOS apps available that work with the ICOM ICR30. So if you're looking to have the most state-of-the-art and feature-loaded stocking stuffer for your first adopter relative, then check out the ICOM ICR30 at your ham radio dealer near you, or go to www.icomamerica.com/amateur to find out more about this amazing portable DC to daylight scanning receiver. And when you finally make that holiday purchase, tell the dealer that you heard about the ICOM ICR30 here on QSO Today. And now back to our QSO. When did you get into satellites?
Actually, just about the time I retired from my job at Wright-Patterson, I had befriended another amateur radio operator, a gentleman from Germany who was working at one of the laboratories there at Wright-Patterson, and again, a ham. And he had been in AMSAT, was a local coordinator for the Radio Amateur Satellite Corporation, which is the official title for AMSAT. And I said, hey, his name was Gert. I said, hey, I'm interested in this satellite thing. And he said, well, here's what you do. You do this, 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 and this. And I said, hey, that sounds like a lot of fun. So this was on my second tour at Wright-Pat. So I had, by that time, I was out of base housing and had my own house and had my own home with a backyard and put up some satellite antennas, and away I went. And one thing led to another. I said, hey, this is neat. And I'll tell you, the first time, because when you're operating on a satellite, you're hearing your own signal. It's like a telephone conversation. So you'll hear your own signal coming back down through the satellite. And I'll tell you, the first time you hear your own voice coming back down through a satellite is as thrilling as the first contact you ever make as a ham radio operator. Shaking hands, sweaty palms and all. It's really a thrill. And but anyway, at that point, I was hooked. I said, this is neat. Because I'd always been sort of a space nut anyway. Back in the 60s when we were going to the moon and they were launching the Apollo and the Gemini spacecraft and all of that. Those of us that grew up in that era, that was pretty heavy stuff at that time. So I've always had an interest in space and all of that. And, of course, as a ham, now we're combining space and amateur radio. And, of course, it was a natural fit for me in that sense. So I had a good time working that. But anyway, I ended up making a trip to one of their AMSAT annual meetings. I believe it was in Washington, D.C. And they were in the process of building Phase 3D, which later became Oscar 40, which at the time would have been the largest and most complex amateur radio satellite to ever be launched. And I remember making the comment, I said, do you guys have anybody that's doing your program, your project management schedule? And they kind of looked at me and said, no. I said, well, I'll help you out. Well, I soon learned that AMSAT is an equal opportunity exploiter. and I ended up as not only working on that Phase 3D project, but I ended up working project management and strategic planning and everything else for the organization. Found myself eventually sitting on the board of directors, and right near the end of 2000 was taking a turn as the president of the organization. So got very much involved in that Phase 3D project, which unfortunately had some serious problems once it was launched, but it was and still is one of the largest, most complex. In fact, if all of the transponders had been turned on that satellite, it would have been transmitting and receiving on more frequencies than any satellite ever launched. So, and it was built essentially by ham radio operators.
Of any amateur satellite or any satellite?
Any satellite. Any satellite. And in fact, we still have one up there, which was launched in 1974. This is Oscar 7. Oscar standing for Orbital Satellite Carrying Amateur Radio. And that satellite was launched, as I said, in 1974 and was very heavily used up until about 1981, when it went silent and the batteries died, and that was the end of that. Well, one of our friends in England was tuning around about 1996, and I think I was sitting on the board. I was the vice president at the time of the American AMSAT group. And anyway, this was a gentleman from AMSAT UK, the English AMSAT group, and he was tuning around, and all of a sudden he hears this CW beacon. And in the satellite band, he was looking for what he called interlopers, people who were using the satellite frequencies that have been set aside for satellite communications for other purposes. Anyway, he's hearing this beacon, and he says, well, yeah, this is interesting. And, of course, one of the other things that right away that you notice about a satellite signal is because of the speed of the satellite, you have a very pronounced Doppler shift on the downlinks. So he was hearing this CW beacon dropping in frequency, and he said, well, that's a satellite, but which one? Well, it turned out that the batteries of Oscar 7, instead of shorting closed, all of a sudden opened up, and because the solar panels that they had purchased, or actually they were given to the folks that were building it at the time, was powerful enough that it could actually overcharge the batteries. But as it turned out, when the satellite was in sunlight, the transponders pop on, and you can use it. And sure enough, that was Oscar 7, came back to life after being silent for so many years. And Eric, that one right now holds the record for being the longest living, still operable satellite that's ever been launched. Not just amateur satellite, but the longest living, still working satellite. It still works. When it's in sunlight, it pops on.
What about Oscar 7, though, in terms of its orbit, makes it unique that it hasn't fallen back into the Earth's atmosphere?
It was in a fairly high orbit. And this was back, remember, 1974. Commercial satellites were just starting to become into force. The only game in town that was doing anything back then was the military and the NASA people, and that was launched on a NASA launch. It was kicked into a fairly high orbit, so it's up there, and it's going to be up there for a long time. So that's one of the reasons why. And again, all the while the solar panels are operating, and it's taking sunlight, it pops on. Now, sometimes it comes on in one mode rather than another. There's two modes of that satellite in terms of the uplink and downlink frequencies. The one will go up on one frequency and frequency band and come down on another, and sometimes it's reversed because there's two different sets of electronics on board. But yeah, it's it's still up there. It's like the Timex watch commercial. Remember, it takes a licking and keeps on ticking.
What kind of setup do you need to have to work Oscar 7 when it is active?
You would need a all-mode VHF UHF transceiver or one 2-meter transceiver and a 440 or 70 centimeter transceiver. Something like a TS2000 or an FT847. In fact, ICOM is just about to unveil a new radio called an IC9700, which I had a chance to look at when I was at the big ham fair in Tokyo this last year. That's an all-mode CW sideband radio. Because it is it's what we call an analog satellite. It works by transposing an entire band of frequencies from the uplink onto the downlink, as opposed to some of what we call our easier satellites to operate, which would be like our little CubeSats that are FM only with one channel on them.
How many satellites has AMSAT launched over its career?
Well, AMSAT North America and its partners around the world, I think we're up to about 95, something like that, since 1961. Amateur radio has been in space back in the toddler stage of satellites. Sputnik 1 was launched in 1957. Oscar 1 was launched only 4 years later in 1961. So we've been in space. Amateur radio has been in space. In fact, Oscar 1 was the very first satellite to be launched as a secondary payload, which, of course, now is mainstream. In fact, we're waiting right now for one of our little CubeSats to be launched out of Vandenberg Air Force Base in California. Hopefully, it's been postponed, but it's going to be flying with 70 other satellites.
Oh, that's amazing.
Yeah. Well, AMSAT, that was Project Oscar, was the forerunner of the Radio Amateur Satellite Corporation, which came a bit later. But yeah, amateur radio has been flying in space on and off since 1961.
How has AMSAT been funded? I mean, 95 satellites. It seems to me that that these original satellites were probably quite expensive to design and build and test before being deployed. How is AMSAT funded?
Right now, it's predominantly, in fact, it's almost entirely from donations. It's strictly non-commercial because, again, we're amateurs and we're not supposed to be doing anything commercial. So it's all funded by donations. And the other thing that we do is our satellites are built essentially by volunteer labor and leftover parts. AMSAT North America has one full-time paid employee. That is our office manager, who is in the Washington, D.C. area. But all the rest of us, from the president right on down to the folks that, like Jerry Buxton, that you talk to on your program, who's our VP of engineering, we're all volunteers, and we're donating our time. We will take donations of equipment. We'll take donations of software. We'll take donations of solar panels and that sort of stuff, and we've done that over the years. But it's all funded basically by amateur radio operators.
Well, that's pretty amazing.
Yeah, it is amazing when you think about it. Now, our launches have also been predominantly donated to us. One of the things that AMSAT does, up until very recently, there's been a couple of other programs that are now designed for smaller organizations like ours to put satellites in orbit. But one of the things that we did back in the 60s and 70s is that we would seek out launches on new rockets. Because in most cases, someone who builds a multi-million-dollar satellite doesn't want to put it on the very first rocket that's going up, because it still is rocket science. And very first rockets of any type sometimes don't make it to orbit. But the way we ensure our satellites is we build lots of them. Instead of building just one, we'll build 4 or 5. And in fact, that's what we've done with our Fox series of these little CubeSats. Which, by the way, that's another thing. This CubeSat design, I'm sure you've heard about it. the little small satellites that are now being launched by the hundreds. That design came out of the brains of another one of our AMSAT members, a gentleman by the name of Bob Twiggs. He and a partner out at Stanford University came up with that design to standardize the size and the shape of these satellites. Because up to that point, when we built a satellite, it would be built around the launcher. Bob said, well, that's kind of silly because then we have to redesign everything each time. Why don't we come up with a standard that we can set up a standard size module for our satellites and put them in a standard size launcher, and then the launcher is the upper stage, the actual ejection system is comparable and compatible with any other upper stage. So there again, here's an example of amateur radio coming out with something that is benefiting mankind. I mean, everybody in the world is now launching these things. In fact, this one, as I said, is what we're waiting for. We're going to be flying with about 70 other satellites from various universities and those sorts of things. So here's another example of where amateur radio has benefited mankind in many different ways. It's in our daily lives.
Are the CubeSats, the Fox series CubeSat or the CubeSat design, is that also the same design that commercial entities that are deploying constellations of satellites, is it the same design that they're using?
Pretty much. We have the way the satellite is put together. It's a 1 liter cube roughly in terms of size, and we build it with internal. It's like a stacked internal boards. In other words, one circuit board will be stacked on top of another. One will be the transmitter, one will be the receiver, one will be the battery, one will be the computer, and then we have 2 or 3 left over. We call it a TSFR. That's this space for rent. And what we're doing is we're partnering with universities around the country here in the U.S. to have them fly experiments that have something to do with advancing the radio art, either on the surface of the planet or in space. We're flying some experiments, for example, with Vanderbilt University here in the U.S. They're interested in looking at what radiation does to off-the-shelf transistors and that sort of stuff, integrated circuits. So they're flying an experiment to do that. And in turn, NASA, the U.S. National Aeronautics and Space Administration, has a program called ELANA, which is Educational Launch of Nanosatellites. And they are seeking out space on rockets that can fly these kinds of satellites. So essentially what we're doing is we're trying to get an amateur radio transceiver into every CubeSat that goes up. So while they're getting their experimental data down, it's coming down as a subaudible or a sub radio wave on top of the voice. They're getting their data. Hams around the world are taking that data and sending it back to them. And then we get an amateur radio satellite to use. So it's kind of a win-win in that situation. So that's helping us get our launches now, which is a lot cheaper. Even though we're getting the launches for free, we're still having to buy the materials and so forth.
And now this message from QRP Labs. QRP Labs has shipped thousands of QCX QRP transceivers kits to date. The odds of working another QCX user gets better every day. If you're looking for a satisfying kit experience where you end up with an amazing performing QRP transceiver for under $50, let me say that again, for under $50, then you owe it to yourself to go to QRP Labs. We have many home brewers who listen to the QSO Today podcast. For you, QRP Labs also has parts, filters, enclosures, and other handy devices to make your home brewing experience even better. You can use these parts to either enhance your QRP Labs kits or to beef up your own homebrew designs. Be sure to browse Hand's entire website. Use the link on this week's show notes page or the one in the sponsored section of the QSO Today website to get to QRP Labs to buy your QCX or any of the other fine QRP Labs kits or parts. QRP Labs is my go-to ham radio kit company. It should be yours too. QRP Labs. And now back to our QSO Today. Well, when we spoke earlier, before we started, I'd asked you about this idea of crowdsourcing Earth stations. Because I'd said that I have an ADS-B receiver here in Israel that puts ADS-B information up on a world map. Do you see ham radio operators crowdsourcing their Earth stations and sending all this data back to whatever points it needs to go?
Well, a lot of them are doing it just because it's another way that they can benefit the hobby in that sense. But yeah, as far as what AMSAT is doing, yes, we are also using crowdfunding and so forth, particularly by our website. There's donation buttons and that sort of stuff on our websites.
No, I guess what I was saying was, like Waze is a crowdsourced technology, meaning it's taking information, speed, and direction from all of their users, and all of that information is being sent to one central place where it then comes back as driving directions and who's around you. So what I meant from crowdsourcing is the technology itself. Do you see that people could make satellite receivers, maybe SDR receivers on Raspberry Pis, and then ferret all that data that they're getting from the satellites as they're flying overhead and sending you information about maybe satellite location and positioning and all of the stuff that you might traditionally get as a single sideband signal or an FM signal?
It's already happening. We have yes, to answer your question, yes, we're doing that. There's a program called Fox Telem, which is downloadable by anybody. And see, of course, that's the other thing we have to remember about amateur radio is that anything that we use or any information that we gather has got to be basically unencrypted. So it's available for anybody to take, and that includes all of the scientific data that's coming down for these university partners that we're working with. But yes, there's a program called Fox Telem, and we've got stations all around the world that are taking telemetry from all of our Fox satellites, and they're feeding that back into a central location. And in fact, you can go up on our website, and I believe, I'm not sure which link it is, but there's a link off of AMSAT.org, and that's our AMSAT, Radio Amateur Satellite Corporation, the U.S. website. It's amsat.org. I don't know which link it is, but there's a way that you can take a look at all of the telemetry that's coming down from all of our Fox satellites, including some of the photographs. We have we have one camera in orbit right now on one of them, and this one that we're hopefully going to be launching this weekend, if all goes as planned. We'll have another camera capability on board. And that you can take a look at the pictures that are coming down from our satellites. So, yes, we are doing that. Maybe not in the same way that you're talking about, but it's the same idea. And we're also, to go back to it, we're also trying the crowdfunding to have people give us some donations to keep all this going. Because even though we're getting quote unquote free launches on some of our satellites, some we've still had to pay for. But it still costs us a significant amount of money to purchase the materials and do some of the testing. The testing is particularly expensive, where we have to shake the satellite, and we have to put it into a vacuum chamber and turn the heat up and turn it down and so forth, just to make sure that nothing breaks or that we don't cause a catastrophe with the main payload, that we're going to be good passengers to fly with somebody who's paying big bucks to launch a big buck satellite.
Are the days of high Earth orbit, elliptical Earth orbit satellites, are those finished now that you're using these CubeSats and LEO in low Earth orbiting?
Just the opposite. We're starting to look for ways to get us back into those kinds of orbits. Up until very recently, the cost of launching something to what would be called geostationary transfer orbit, or a television, basically in a television satellite type orbit, were cost prohibitive for an organization like AMSAT, upwards of $6 to $10 to $20 million. You folks on your side of the pond are very quickly are going to have a geostationary satellite capability, because our friends from AMSAT Germany have been working with the government of Qatar, and they have just launched a satellite successfully. It came out of Canaveral, is in a geostationary transfer orbit at the moment, and as I understand it, is going to be parked somewhere down over Africa, and will give the European, and I think the footprint stretches from just about the tip of South America, the eastern tip of South America, all the way over to Thailand. And it's going to be essentially a geostationary satellite transponder. It's flying on one of the TV satellites from Qatar. So you folks are going to have a chance in your hemisphere to be able to operate amateur radio's very first geostationary satellite. We're not going to be able to do it in this hemisphere, but you folks over there will be a chance to have to do it. The channels, they're going to have an analog 2 meter 70 centimeter, I believe. Well, no, I don't think it's 2 meter 70 centimeter, but you'll have an analog uplink. There's also going to be some digital uplinks and downlinks on that satellite. It's called S-HALE 2 is the name of the satellite, and I don't know what the German transponder is going to be, Oscar something. But yeah, we're getting to that now. As far as what we're doing over here, there's a program called GOLF, which is the follow-on to FOX, and GOLF stands for Greater Orbit, Larger Footprint. And what we're going to be trying to do is to get some of these CubeSats into some higher orbits to test positioning, antenna positioning, and those sorts of things. There's another project that's coming around with NASA to put amateur radio on the follow-on to the International Space Station, which is going to be out somewhere in the vicinity of the moon. That's a program called Gateway. So to answer your question, you asked me what time it was, and I'm telling you how the watch is made, but essentially the answer is yes. We're going back to that kind of an orbit. Whether that will happen tomorrow or next year is probably not, but we're trying very desperately to do some other things to get us to those orbits.
Now, it's my understanding, I mean, I've known this for some time, we have a project here in Israel called Space IL, which was part of a Google contest to essentially put a privately funded, maybe it's now nationally funded, spacecraft on the moon. So there's kind of this competition underway. Do you think that ham radio is on any of these projects, and that we may have a moon-based repeater at some point?
That's been a dream of a lot of people, is to have some sort of a transponder or something on the moon. There was a project back when I was president of AMSAT called Moonray. Never went anywhere. But one of the problems that you have to remember is that anytime you put a satellite into orbit, whether it's an Earth orbit or whether it's a lunar orbit, is whenever it's in the sun, it's baking at 250 degrees Celsius. And when it goes into shade, either into shadow around the Earth or in some darkness, it's cooling at minus 250 degrees Celsius. So one of the big problems that you've got of anything that would be sitting on the moon facing the Earth, you're basically in sunlight most of the time. So you'd have to figure out a way to get rid of some of that thermal energy. And the only way you're going to do that is through direct contact, because fans don't work and heat sinks don't work in those kinds of environments. And that's always been one of the challenges. Now, on the other hand, hey, if somebody's got a plan to do that and can come up with the technology and the half-baked ideas to make it work, fantastic. I'm not aware of anything other than the Gateway project at the moment, but who knows? You know, the sky is no longer the limit, Eric.
Does AMSAT benefit from the technology that we now deploy in cell phones? It seems to me that there's a lot of industry, including the industry that I'm in, that I'm really benefiting from the fact that the cell phone technology is prolific and cheap. Are you using cell phone chipsets and things like this in these Fox satellites or these Cube satellites? And how do you make them work with the extreme temperatures?
The answer is yes. And in fact, it has been the enabling mechanism to bring the satellite sizes down from something on the order of a basketball, or in the case of Phase 3D, the thing was 6 feet across. We're now down to the point where we can tuck a lot of the technology that we had in just flying what would be called a microsat, which would be about 9 inches on a side, down to a CubeSat, which is essentially a liter type size. And it's all been because of the fact that we've got these very small chipsets and that kind of miniaturization that's come in the same as the cell phone technology. So it's whether, it's a chicken and the egg thing, whether what we've done is benefiting the cell phone industry or whether it's the other way around. The other thing that we're experimenting with, and we're going to have to do this if we go out to any kind of a distance away from low Earth orbit, is positioning. And now you're talking about little gyroscopes and these little things that would help us to stabilize the satellite so that we would point the antennas back to Earth at such times so that we get a little bit of gain, because that's the downside of the miniaturization, is that you can no longer put the real heavy high gain antennas on these satellites. Now you're just basically looking at little whip antennas, something that would be on the order of about 19, regular 2 meter, 19 inch long whip, or a little 70 centimeter whip on these satellites. So that's the downside, in that we can't really get a whole lot of gain because there's not a whole lot of surface area on these smaller satellites. Now, in some cases, and what we're looking at is stacking them one on top of another. So in other words, a single satellite, single CubeSat would be what we call a 1U, but you could stack 3 of them together to have a 3U. And in some cases, that's what's happening now. That gives us, maybe put some deployable solar panels on us, give it a little more power. You could put a little more heftier batteries in it and a little more electronics and some more experiments, and there's all kinds of opportunities to do things that way.
Looking at your pictures on your website, I noticed that you use a lot of egg beater antennas. Is that the antenna of choice for a fixed home satellite station?
Egg beater antennas are great for what I would call overhead passes. If the satellite is, again, low Earth orbit, and the satellite pass from horizon to horizon is going to be about 45 degrees above your horizon at any point, egg beater antennas work okay. For anything other than that, you're going to have a little bit of gain, and that's where these little arrow antennas, and you see some, if you're looking at my website, you'll see me holding an antenna, a handheld antenna. It's a three element Yagi for 2 meters, and it's about a 6 or 7 element Yagi for 70 centimeters. That gives you a little bit more gain, and you can get away with using a handheld, for example, on one of our FM satellites. So, you can use a small handheld radio like a TH87 or so, something that can do hopefully full duplex. Or a lot of folks are using these little Chinese radios. Instead of just one, they'll use 2, one on 440 and one on 70 centimeters, and a little handheld antenna. And those things don't have to be commercially made. You can make those out of pieces of wood and welding wire. There's lots and lots of designs up on the internet to help you make those things. So you asked one of the questions, how expensive is it to get into this? It's just like anything else. You could go very, very inexpensively, or you can have your house starting to look like a NASA tracking station. It's up to you.
I remember seeing that the original satellite guys actually had antenna arrays that were almost looked like moon bounce arrays.
Yeah.
To track the satellites as they're coming over the horizon and follow them for as long as possible. But that doesn't seem to be the case anymore. Don't
need to be. In fact, there's enough gain now in a lot of our equipment that even though the satellites are usually putting out anywhere, something usually less than a watt of power, half a watt to a watt is usually about it for a low Earth satellite. With that little handheld antenna with 6 or 7 elements for 440 and 3 elements for 2 meters, that's more than enough to get you in when there's not a lot of contention. Now, you have to remember that these little satellites, there's single channels. So you're in essentially you've got a repeater on a 500-mile tower with one channel. So you're within range of hundreds and hundreds of stations. So there's a whole protocol that's evolved about how you work these satellites too. Most of the time, it's not long-winded conversations. It's usually a call sign. Hi, Joe, how are you? And then you'll give maybe a grid square of where you are. They'll give you a grid square, and then that's it. Let somebody else use it. It's very, very short communications because there's so many people trying to work it.
Do you see a day when AMSAT could build a constellation of satellites similar to what the commercial guys are doing in order to create perhaps a satellite internet that's ham radio?
It could happen. Right now, we've got some of our Chinese friends, the Chinese AMSAT group, launched 6 or 7 satellites back in 2015 off of a single booster. And they're spread out in orbit. And essentially what you can do there is, and I've done this, as one satellite comes over, you track it overhead, and you can have a conversation with a gentleman or lady comes along. And then as that satellite sets, you swing your antennas around 180 degrees, and you pick up the next one. And you can carry on a conversation. So we're doing some of that already. But yeah, the answer, one of the things that we're going to be looking at with this golf series is to see if there's a way that we can communicate between satellites. And that's one of the technologies that NASA would like us to be looking at. So that's possibly going to be something to do. The other thing that's becoming an issue now is debris mitigation. There's so much stuff floating around up there that at some point we may be trapped in the sense that we can't get out of low Earth orbit because there's so much junk flying around at 17,000 miles an hour. Organizations like NASA here in the U.S. would very much like to see some experiments of how to deorbit some of these smaller satellites when they are no longer functioning or they're no longer needed. So there may be some exploration opportunities for organizations like AMSAT to go test some of these technologies in orbit to see if they work. And then, again, if we can put an amateur radio transponder on some of this stuff, then we also get an opportunity to have another amateur radio satellite in orbit. I'm not saying that's going to happen right away, but I think that's where we're eventually going to go. And again, an amateur radio is in a position, because we are a nonprofit, we're not worried about the profit motive. A lot of our work is being done by volunteers. We're kind of the Wozniaks and the Steve Jobs of the satellite world, because we're doing a lot of stuff in our basements and garages and coming up with some of these new concepts that some of the folks that are trying to worry about stockholders and profit margins and all of that sort of stuff are not going to be able to do. And again, this is one of the wonderful parts of amateur radio, in that not only can you have some fun doing what you're doing, but it's also providing a service for helping mankind down the road in the world of space. And let's face it, that's the last frontier at the moment.
What do you think is the greatest challenge to AMSAT right now?
Funding. I'd have to say, as the treasurer, I can tell you that right now, some of the stuff that we're doing is costing an awful lot of money. As I said, even though we get quote unquote free launches, it still costs a significant amount of money to buy the materials, assemble them, test them, and do all of the troubleshooting and stuff that has to happen to get the satellites built. We're a nonprofit organization, very much 501. In the U.S. would be a 501c3 organization. That's AMSAT North America. There are other organizations around in the world: AMSAT Germany, AMSAT UK, AMSAT France. I'm not sure there's an AMSAT Israel. There may be. But all of these other organizations are trying to build satellites essentially on a shoestring. And so what we end up having to do is, a lot of times we have to dip into our dwindling reserves to initially fund the building and the buying of the material. and then hope against hope that we can raise the money to return that money that we've had to pull out of reserves to replenish the coffers so that we can turn around and do it again. So right now, that's the biggest challenge, is funding. We've got lots of folks, brilliant people, that we've brought on board to build and control our satellites. And that's the other thing, is we're not only do we build them and launch them, but then we have to control them and make sure that, take their temperature and make sure that everything's still working. That's all done by volunteers on their own time as well. So I'd say right now that's the biggest challenge that we have, is looking for sources of funding, not only within amateur radio, but outside of amateur radio. And haven't even talked about the ARIS project, which is the amateur radio on the International Space Station. That's a project that's under the wing of AMSAT at the moment, in cooperation with NASA and the Russian Space Agency. But that program, where we have the school kids talking directly to the astronauts in orbit, that thing changes lives. I mean, that is just to watch those young people talking voice to voice with an astronaut or a cosmonaut is just mind-boggling, to see the impact that it has on young folks looking to enter into what we call STEM, the science, education, engineering, and math type careers. Just absolute fantastic project. Again, all done with volunteers and donated labor, leftover parts, and donated funding.
What excites you the most about what's happening in amateur radio now?
I would say the technology that's coming down the road, and the fact that we continue to push the technology forward. I like to think of amateur radio and even AMSAT. I like to think of us as the sandbox of electronics and communication. A lot of the protocols that we take for granted on the internet all came out of amateur radio. A lot of the secondary payload launches that came out of that we now take for granted to launch satellites, that all started in AMSAT and its predecessors. So I'd say that the fact, and this is one of the things that keeps me excited about working with AMSAT, is that I'm surrounded, even though I'm not really a techie guy, I'm more of an operator, and my forte is in the financial side of things and the management side of things, but I'm working with some brilliant people who have done some fantastic things, both within amateur radio and outside of amateur radio, that you and I now, because of cell phones and all these, that whole concept of cell phones came right out of ham radio, that we take for granted. And we were thinking the other day, where would we all be without our smartphones? Hey, that's where we came from. This is what we've done in the past. So, but on the other hand, we're having too much fun to think about it, right?
Right. It's an amazing time to be alive.
Absolutely.
What advice would you give to new or returning hams then to the hobby? Get
involved. One of the things that, as I said earlier, our organization, AMSAT, is an equal opportunity exploiter. If you've got a technique or something that you could contribute to what your organization, whatever your interest in amateur radio is, there's always something that can be done to give back to the hobby. And that was one of the things that both of my elders told me when I first started out, is give something back. Do something that will benefit the hobby and take it forward. And that's, I think, one of the things that I would say to new hams is, get your feet wet, go play the DX and do the repeaters and all the other things that go with it. But start looking around to see where else you can make a difference, whether it's with your local club, whether it's being an examiner, and that's another thing. I'm an examiner on both sides of the border here. I'm in Canada as well as the U.S. Give something back, because it will come back to you in spades. And in my case, as I said, working with AMSAT, I have met some fantastic people. I mean, where else in the world would a guy who grew up in rural New Hampshire be able to sit down across the table from a NASA astronaut and have him tell you what it's like to fly on the space shuttle? And I've done that and actually had people where I've sat across the table from some of these folks that have been in the space business for a long time. It's just mind-boggling. So don't sit on your hands. Don't just take it all for granted, because it isn't. You know, our frequencies are under a lot of stress right now, particularly those in the microwave region and above. Get active, get on the air, make some noise, and go volunteer in whatever way you can. Like I said, with a local group, emergency communications is another big part of what we do. And as I said, if you get tired of one thing, you can always do something else. We'd like to see an AMSAT, but hey, whatever it is that floats your boat in the ham radio, go do it.
Keith, this is a great time to end. Although, frankly, my sense is that we could probably talk for another couple of hours. But I really want to thank you so much for joining me on the QSO Today podcast. I've learned a lot about AMSAT, and frankly, these are questions I've had for some time, so I'm glad I had a chance to ask them, and I'm glad I had a chance to have you answer them. So with that, I want to thank you so much and wish you 73.
Take care. Thank you. Always a pleasure, Eric.
That concludes this episode of QSO Today. I hope that you enjoyed this QSO with Keith. Please be sure to check out the show notes that include links and information about the topics that we discussed. Go to www.qsotoday.com and put in KB1SF in the search box at the top of the page. My thanks to both ICOM America and QRP Labs for their support of the QSO Today podcast. Please show your support of these fine sponsors by clicking on their links in the show notes pages, or when you make your purchases, that you say that you heard it here on QSO Today. You may notice that some of the episodes are transcribed into written text. If you'd like to sponsor this or any of the other episodes into written text, please contact me. Support the QSO Today podcast by first joining the QSO Today email list by pressing the subscribe buttons on the show notes pages. I will not spam you or share your email address with anyone. Become a listener sponsor monthly or annually by clicking on the sponsor buttons on the show notes page. I am grateful for any way that you show appreciation and support. It makes a big difference. QSO Today is now available on iHeartRadio, Spotify, Libsyn, and TuneIn, as well as the iTunes Store. If you own an Amazon Echo, you can say, "Alicia, play the QSO Today podcast from TuneIn." I still use Stitcher to listen to podcasts on my smartphone. The links to all of these services are on the show notes pages on the right side. Until next time, this is Eric 4Z1UG 73. The QSO Today podcast is a product of KEG Media Inc., who is solely responsible for its content.